Okay, so everyone can see the screen in the slide deck, right? So this particular topic is very important in terms of understanding how Hadoop ecosystem works. It's a part of continuation of what we studied in the previous class. Just to check, Kumi, are you able to hear me in the Zoom link?
Yes, I can hear you. Can hear you.
You can just message me, right? Just send a chat message that yes, you are able to hear or not. Kumi, are you able to hear us?
Hello, Prof.
I'm not good, right? No, you are not. Okay, that's fine.
I can hear you.
So the Hadoop and Hadoop ecosystem is an important concept when you do the Hadoop installation and you would like to integrate with the other system and the software that comes as a part of integration or the entire ecosystem. Okay, in standalone terms, Hadoop just runs over a data node and the name node, right? You have that folder created on your assignment, right? When it is executed, the only challenge is you have to do everything through command prompt, right? All the things you are doing is a command prompt, and not every user applications are so easy to work it out through a typing the command, right? So what it happened was the core Hadoop is then integrated with the multiple other systems called as Hadoop ecosystem. Basically, what all things that come as part of a package. Okay, when I say package, it means what all software that can get hooked up with the Hadoop core system. Okay. So there are some reading material which you all can read it. I'm not going through this. The source of the information is taken from these sites. You can go and read through these sites in terms of getting the details of what ecosystems are and how are they integrated. But don't worry, I will get you more details in terms when we move to the different slides. Okay. So this is about Hadoop ecosystem, when and where it started. The history is Nudge project was started by Doug. In 2002, Google released a white paper on GFS, that is Google File System. Google released a white paper on MapReduce in 2004. They implemented MapReduce in 2004. Then Hadoop started as a sub project in 2006. Yahoo started using Hadoop on thousands of nodes in cluster in 2007. Hadoop became top level project at Apache in 2008, and henceforth the year-over-year history of the Hadoop, how it was basically upgraded year by year, right? Again, it's more of a history part. I don't think that's important. This page is very important for you all to understand what is Hadoop ecosystem. Hadoop ecosystem, as I said to you, it's an integration of different systems that are connected to Hadoop to perform the various actions. Okay. So first I will read it and then I will explain you. Let me first read it. These Hadoop components are different services deployed by the various enterprise. We can integrate these to work with variety of data. Each of the Hadoop ecosystem component is developed to deliver explicit function, and each one has its own developer community and release cycle. So basically, if you look at the core Hadoop system, okay, Hadoop system consists of HDFS file system, that is Hadoop distributed file system. It consists of something called as YARN. YARN stands for yet another resource negotiator, and then the third is called as MapReduce. Whenever you install Hadoop, you will have these three systems in your place, right? When you deploy it as a package, you will see these three things always being there. Okay, this is the core system of Hadoop. What does HDFS file system do? HDFS file system stores the file data, right? So as I told you in the previous class, if you have a huge file, how that file will be split and distributed into different data nodes, that is a task which Hadoop distributed file system does. So if you remember, as a part of your assignment, you did this you gave the source path minus put, and then you gave the HDFS file system path, right? What were you doing? You were trying to load the file which is there as a part of source system to a Hadoop distributed file system. So this particular component of Hadoop basically helps in loading the data to the distributed file system. Okay, so when we talk about file system, think about file system is like a regular file system which you have in your Windows directory. For example, your Windows will have a file system as a NTFS, right? New technology file system. Unix will have a different file system. Your Mac will have a different, Mac OS will have a different file system, right? Similar to that, Hadoop also have its own defined file system. Basically, the file system, what it does it splits the file into smaller part and stored into different data node. As part of your assignment, you have created one node as name node and one node as a data node, right? Because you are running it on a single machine, right? Think about you have a large pool of clusters of hundreds of machines, and I have 100 GB huge source file. I have to split that file and store the small chunks of file in each of the different cluster node machine or data node machine. The task will be done by the Hadoop distributed file system. You don't have to worry how the file will be split, when will it split, where it will be stored, you don't have to worry about it. Okay, we will discuss about who takes care of that. That's the job of Hadoop distributed file system. Concept is simple, divide and conquer. Okay, dividing a big file into smaller chunk and concur it means saving it to a certain file location. Okay. Then the second component is again a core component called as yarn. Yarn is basically a resource manager. How the data node will be used, when it will be used, which data node is available, which data node is not available, which can take more requests. All this process management task is being performed by yarn. Okay. So think about this as a person who is basically monitoring and managing the resources within the yarn cluster system. Okay, so since you have your assignment with one data node, one name node, so you don't know yarn will be much useful to see. You cannot see it because it's only one node, right? But if think about there are hundreds of data nodes which are connected to each other through a name node, and we need a mechanism whereby we can orchestrate and synchronize different data nodes to work efficiently. That process and that task is being performed by yarn process. Third is MapReduce. Task of MapReduce process is simple. What algorithm which we studied, which is called as word count problem. There was two processes that will initiated. One is called as mapper and second is called as a reducer. What was the job of mapper? Once the file is uploaded into Hadoop distributed file system, mapper will, when you run that jar, right? Or when we will do the next assignment where you will write a Python script to do the mapper process and the reducer process. What is basically doing is when you map reduce program, basically what it does it will send those command or send those map command to all the data node. Okay, so the mapper what it will do, it will open the file which is split here, right? Each of the data node, open the file, read each and every line, assign each word a key value pair, right? Assign each key value pair, then that part is called as mapper, and then subject send another request called as a reducer. What will reducer do? Reducer will then sort it out, shuffle it and combine together to form an aggregated list of number of word counts that are there, right? So that entire task is being performed by the MapReduce processing. So if you see the Hadoop core system is this only three, right? But the problem is if you want to do multiple enterprise-wide business operations, right? This three is not sufficient. When I'm saying not sufficient means you want to do these processes like splitting of the data, processing it, finding it, reading it, writing it, but you need some interface, right? Some place where you can log into UI and do the process which is easy to be understandable by user. Okay, for that those packages are built over it. Okay, so I will go one by one. So if you see there is a table schema management, one is pig scripting and Hive. This particular package gets installed over Hadoop. Okay, so whenever I say install, basically you don't have to do much of the work, just download that package Hive SQL and then install on your machine. We will do this. Okay, we'll install the package in Derby, and this particular package will be useful for writing the queries. Okay, writing the SQL type SQL queries that can call internally the MapReduce process and fetch the records and give it in the UI. Okay, then there is a package called as Apache Drill. There are many others package. Again, this is very limited set. So this particular package is used for machine learning process. Again, the programming will be written here as a part of UI, but the processing will be done through the help of all these three items. For example, if I have to do a machine learning program, if I'm using any package here as a software, what I will do, I will through a package, I will send a request to upload the file, right? I will get that file loaded into HDFS file system. Then I will send a command, some request from here to run the map reduce over that particular data set. And we get the analysis through machine learning programs. Then the third ecosystem is called as Avro JSON. Again, this is type of package which is used mainly as a part of a cross language services, or I will call it as a schema driven services. So you know about APIs, right? So there are APIs like SOAP API, REST API, right? Within REST API, there is a format of API which is called as JSON Avro. Okay, JSON, have you ever seen JSON request response payload? Let me pause so that you all can understand what I'm saying. Okay, so normally what happens when you see the REST API, right? REST will be what? Post, get, put. You will see these methods, right? And when you see this method, you will have the endpoint API URL, right? Which will be like this https:// locus. I'm just writing it like that, right? And in the end, it will have customer info as a method function, right? And within the body, what you will write here, in the body, you will have something like this, right? Right, and then you will send this post request. Have you ever tested API? No. Never seen Postman collection, SOAP UI collection? Okay, think about this API as a middle layer service which connects front end to the back end. Okay, so front end doesn't understand back end doesn't understand front end. So basically you need someone as an interpreter in between that can talk to each other or act as a communication medium. So if you have a front end sends any particular request to the back end. The API actually helps as an intermediate to translate that request into a format which backend can understand. So when you send a request to the backend in a form of REST API, REST is a type of service format. Okay, there are two types, SOAP and REST. Okay, so if you send it as a form of a REST, the structure is like this. So you will have a URL which will tell that, okay, hit at this URL. So front end guy, developer will actually point his code to this URL. This URL will expect some format of input data. So that input data is passed here, and this particular request goes to the database at the backend. Okay. And then backend will respond and it will be returned in a form of a REST response. Okay, REST response again in the form of something like this. This response is again sent to the front end by truncating unwanted thing and shown in the front end. Okay. So this particular REST API format can be a regular REST service or can be in a form of something called as JSON. It's called as Java service, some notation. I don't remember the full abbreviation. Okay. Java service over notation. Object notation, right? So if that JSON request payload and the response is there, if that schema design for that JSON is Avro, there is a one schema design method of designing those JSON services. If that Avro schema is there, then you need to use this type of package to run your request and response. Okay. So this is more in the part of the machine learning query and the API layer. If you see on this side again, this is not limited to only this many ecosystem products. There may be many others. I'm just highlighting the ones which are very commonly used. Okay. If you see on this side, there's one component within the Hadoop ecosystem is called as HBase. It's a columnar store. There is another package called as Scoop. It's all for data collection. The third package is called as Flume. That is for again for data collection. Again, these are products. Okay, that gets hooked up with the core system. So I'll just read it. Another one. Okay, I will come later on this one. So see this Scoop is help us to load the process data directly into Hive or Hive database. So this particular package Scoop can be used to load the process data. If the data is already clean and I want to load it, then you can use this package. Flume is collecting, aggregating and moving huge amount of stream of data from external web server to the central store such as HDFS or HBase. If a requirement in your enterprise is to do some form of collection of the data, aggregating means adding or combining the data, then you need to use this package. Okay. Then you have Pig is used developed by Yahoo, which works on Pig Latin language, which is a query based language similar to SQL. If you want to write some SQL statement to extract the data from the database, which is stored in Hadoop distributed file system. Normally in traditional way, what used to happen here, this 3 was not there, right? Here the database was there, right? Normally a database was there, and the front end you will use through SQL Server UI, right? You will have this what you call it as a SQLite or whatever, DB visualizer. There are many tools, right? Tool for Oracle application and development, where you can write the query. That was directly connected to the database. Now we are not connected directly to the database. We are connected to the big data system here, right? So in order to interact with them, we need some package of support that can interact with the split data which is inside it. On the left hand side, if you see the ecosystem, these are all monitoring aspect of the Hadoop. So if this is core processing, this is for application, this is for loading and extraction, this is for monitoring. How is your system performing, right? So someone has to monitor it, right? So there is one package called as zookeeper or coordination. It's like a zookeeper in a zoo. What does a zookeeper do? It tracks where all the animals are, how they are, when they are doing their work in scheduled time. Zookeeper basically what it does, it monitors the resources. Similar to what Yarn does. But if you tell every task to be monitored by Yarn, it overloads the Yarn. So basically to avoid the overloading, we created a package called a zookeeper, which actually monitor and controls, or what you can say, like it basically does the resource management, how the resources will be split, which resources will be given more tasks, which resources will be given less tasks, and all those tasks can be managed by zookeeper. Something is called Apache Ambari. This particular package is used for visualizing the monitoring aspect of it. It's a system monitoring. Like if you right click on your taskbar in Windows, you see the processes running, right? How much CPU, how many memory is utilized. Think about a big cluster of system you want to monitor. So it's a dashboard where you can log in and you can see all list of clusters, all list of hosts which are running over the system. So you can see which resources is highly utilized. If you want to restart particular host, if you want to pause, if you want to suspend any process, you can do it from Ambari monitoring dashboard. Okay. Is this clear?
Yeah.
Then you have Uzi. Uzi simply perform the task of scheduler, thus scheduling the job and binding them together as a single unit. So if the process within your organization needs to load a data at a particular time in the night, or if you have to load the data into parallel processing, if you have to load the data into certain fixed interval, you want to do a scheduler, then the scheduler is being used through Uzi system. Again, you all can do these all stuff without these. But the problem is, if you want to do a SQL query, you have to write a full package here, full Python script, right? Nobody will write that, right? So if the package is available, directly use it. If I have to monitor it, I can monitor Yarn through command prompt also, right? And a browser which when you did your assignment one, there is one snapshot where you can log in and see the leaf node utilization. You can do it from there also, but you need a better enterprise-wide usage pattern to see how it is going through hundreds of clusters. In those cases, Zookeeper can help you. If you have to run any form of a columnar store, so basically this is HBase is there are two types of data storage pattern. One is called as row store, another is called as a column store. Okay, the difference is any data which you need in a quick time, you store it into your main memory. Okay, any data which you don't need so frequently, like a monthly report, or if you think about bank statement of 3 months, 6 months, you don't frequently check it. So we store those data into form of a column store in the disk. Okay, so any transaction which requires a very high level of transaction processing capability, like hundreds of thousands, millions of transactions going in 1 second, like Google, you want to do a search, you store those data in the main memory, basically in the RAM, so that your processing speed is faster. Any data which is not so frequently accessed, you store into the column, that is called as disk. Now you will ask me which data should I keep in main memory, which data should I keep it in a disk? That depend on the architectural design of your data set, right? So someone in the architecture team will analyze all the tables, analyze which data is being frequently used, which columns are frequently used. It will take that data, partition it and put it in the main memory. Which data are not frequently used, you will put those data into the disk. Again, when I'm saying not frequently used, it doesn't mean that it will be used 10 days. No, it will be used, but maybe once every 10 minutes. Versus you have one transaction running at 100 transaction every second, right? Yes.
With this analogy, where does microservices come in and SOE comes in those services?
Okay, let me explain you, but I will explain you for 5 minutes, okay, not more than that. Okay, microservices are different than big data. First of all, understand that, okay? Microservices run on containerized environment. Okay, so you need to understand what is containerization. Think about you, everyone has seen Amazon website, right? Let's say I have an Amazon website which I launch a URL. Okay, I log in with my user ID password. Okay, search a product. Let's say I search for iPhone. I get a list of product. Select a product, add to cart, proceed to checkout, do the payment, get an order number, log out. This is a flow, correct?
Yeah.
Now, in a traditional way, when the development used to happen, how do they used to do? They used to create a master branch. They will create a source branch where every person will take the function and method within that code and try to modify it. Let's say I want to add a search field with a special character. So I will download the entire code in my local laptop, right? Entire package, right? So let's say that code is 50 gigs. I download on my local machine. I make that code modification. I change the code. I test it on my machine. Once everything is fine, I push the code into the main branch and merge it, right? The code is running fine. They will test it and they will deploy it, right? I am not the single developer, right? I'm not the single. So there are 10 other developers who are working on that project. Let's say you are working on the payment page where the credit card information is given, and I was working on the search page. When I merge and you also merge, then there need to be sync, right? Because my change will not go, your change will go. If maybe both changes are not going, both changes will have a conflict, right?
Yeah.
So in order to resolve that, there were mechanism to fix it, but the time impact was huge. Because every time when the deployment used to take, it used to take a lot of time because everything has to be verified start to end, right? The concept of microservices and containerization came with this problem to be resolved. You understood the problem, right? Because everyone has to work it out to fix it. The problem to resolve was done through a concept of containerization. Now think about all the steps which I told is broken down to each and independent modules. Okay, so let's say there is one module called as launch. Okay, other module is called as login. Third module is called as search. Right, fourth module is payment. Right, and fifth is logout. This is all function, right? This is the Amazon page function, right? Initially, when I used to make changes in this and this, I will merge it, bring the server down, entire server will be down, compile the code, push it, right? And make the IaaS server run again, then everyone will use it, correct?
Yeah.
Till the server is down, is there any business running?
No.
Everything is dropped, right? Now think about it, if I put this all code into a separate module. Separate module, you understand?
Yeah.
Separate bucket. I call that bucket as a container. Right? Now a launch team, that's why you will see agile team, right? They call it agile team. Why they are calling agile team? Because each team is doing their own feature enhancement at the same time, right? Now let's say a particular day, login team is working on particular authentication. User ID, password, they're putting some security code, and search team is adding new product to the list, right? iPhone was searched, now I'm adding Android phone to the list, right? If this person has already done the work, they don't have to depend on other people, right? They can simply deploy their piece of code, right?
Yeah.
Everything will be running as it is. If this particular portion was search was down, they are making changes on this particular code. Is this available?
Yes.
Is this available?
Yeah.
is this. So if Amazon has to change add a particular product, let's say Android phone, do they need to bring the entire system down?
That's all.
You can still launch the URL. You still can log in. Nobody is stopping you. You can search any other product and you can do the payment as long as it is not Android, right? Rest everything is working. Now, if I put these all module as a service, when I say service, like an operation, because end of the day it will call the database, right? Through an API, as I explained here, right? This will call an API through a database. Everything is called through an API to a database. If I host each of the services into a smaller servers, think about smaller machines. That is called as microservices, right? Hosting a services into a containerized format into an individual resources is called as containerization. Okay. What will happen is when you are bringing a particular service down, so let's say this service was not working, you are modifying, you are deploying the code. You don't have to bring all the services down, right? They can still run as a container.
Yeah.
If any problem comes in a particular component, you just bring that one down, fix it and push it up, right? So the entire deployment process is very smooth. Earlier, the deployment process used to take days to do it. Maybe it starts at 8 o'clock in the night. So you would have seen maintenance. Many of the websites you will see maintenance from 8 o'clock night to morning 4 o'clock. Now maintenance doesn't go more than 2 hours. Why? Everything is moved to the containerized concept. We don't deploy the entire code. We deploy the code by piece, right? The another advantage is, in case of containerization, let's say this is an example of a Boxing Day or Amazon Prime Day, right? Where will be the most of the stress happening? Most of the stress will happening in the search of a product or a product which are in discount, right? If I have services all hosted in the same type of server, let's say each of the services are hosted on 4 gigabit RAM machine, 4 core, right? This will exert maximum load.
Yeah.
Right? My pain area will be this, right? Not this, right?
Yeah.
Everyone will start searching, querying database, right? What I can do is I can uplift it.
Yeah.
I can vertical scale this only, not these others. I don't need others to be scaled up, right? If I push this entire code to the cloud, I gave you an example of standalone. If I put this entire code into the cloud, this is one server, this is one server, this is one, this, right? All of the services are hosted on different machine servers in the cloud. If I see a load is in this high, I can just spin up new virtual machines in the production for the time being when the load is high. Once the load is down, I will decommission. What I am doing, I'm saving the cost, right? I don't have to buy all the machine for everything, right?
Yeah.
If the load is very low, why should I waste the resource by giving the pay as you go concept, right? I will reduce the load. Someday I know our traffic is very high, I will increase this to a higher virtual machine. All this containerization is done through a concept called as OpenShift. It's a Linux product running over running over cloud. Okay, you can run it in Amazon cloud or you can run in Azure cloud. But the concept of microservice is tied up with something called as OpenShift container, OCP. So whatever services I told you, they are hosted on each of the container pods. Okay, so whenever in the production, when we see that, okay, this service is stressed out, used at high utilization, we quickly spin up a new pod. It's called as pod in. And again, the technology is so advanced, we don't have to spin it up. There is a mechanism called as auto scale. So if the limit is set as 2 to 4, and if you reach to 3 pods utilization, automatically it sees auto scale to 8. So you never get a downtime. So reliability is close to 99.9999. Okay?
Yeah.
So that's the concept of full microservices. This right now you are doing in your local system, you will not see this containerization concept. Okay? Clear?
Yeah.
Good. This was a little bit out of topic, okay? So basic Hadoop is an open source. Do you want me to read this? I'm not reading it. I'm only reading the specific topic line called as Hadoop is designed to operate in commodity machine. That's the most important line. Your slave machine or the data node machines are called as commodity machine. Why it is called commodity machine? Because they are low powered machine. The task of low powered machine is only to store data and follow the instruction what name node has given and told them to do. It's like a teacher teaching to a student. You are not entitled to do anything until it's what I tell you to do, right? So as a part of the heavy lifting, you are only holding the data and the instruction which I am telling to process it.
I was thinking they were not doing the job. That from last week's lecture, the slaves, they were doing most of the job.
Slaves are doing the job of only running the instruction which was given.
Okay.
Is it managing any resources? Is it holding any operating system? Because again, it's holded on your own local machine. That's why you feel like, oh, it's running on my operating system. Think about your master node is running on one big server, right? And all the data nodes are like a dummy servers having 4 gig of RAM and 2 cores. If I give one instruction and a small file to process, how much load it will take? It will not be a heavy lifting, right? So that's why it is called as commodity machine. Performance of single machine is getting less and less important. So again, the concept of cloud has been used here. You don't do the data node setup as a static setup in production. Now what we do is, depending upon the demand and need, we spin up those many data nodes. Why to take extra VM machine as a slave node when we don't need it? If we need only 10, we'll use 10. Tomorrow we don't need for any processing, we'll bring it down to 2. Right? So it saves the cost also. Okay. Hadoop divides large file into the blocks and store them in different cluster nodes, thus making system highly fault tolerant. Okay. The rest other things you can read it. Okay. Anything you want me to explain in this? Just a gigabit. Data from input streams are never changed. The write once model. What does it mean? Whenever the data is written to the data node, it's only once written. Okay, it's not written multiple times. Basically means you write it at one place. You write it at one place and you replicate it. Did I tell you replication last time?
Yeah.
So there is a master node and there are data node. Like think about your laptop, you have one name node and one data node, right? If your data node doesn't start, can you run your map reduce? It will not run, right? Because the node name will send a request to data node and data node will not respond. In order to give it a fault tolerant concept, what we do is whenever we used to write a data in the data node, we create a replicas of it. So that if one data node is down, we can pull the data from the other data node. Okay. High level architecture, the processing model works on the data locality where computation logic is sent with the data to the nearest cluster node. Data locality, did I explain you last time? Yes. People don't read. Anyone in the class who can tell me what is data locality?
So the data that resides on the main memory.
No, it's just opposite. Anyone in the class who can tell me what is data locality? Locality means what?
Location.
My locality is a certain location means what?
I mean,
I'm residing there, right?
yes.
In a traditional approach, in the old way, this was your master server, right? This is the old traditional way. And you have one database here, one database here, one database here, and one database here. Okay. In the old method, what you have used to do is, if I have to do a processing from multiple data sources, hear me out, when I'm doing a data processing from multiple data source, my master server used to do what? Used to pull the data here, pull the data here, pull the data here, pull the data here, club all the database together, join together through form of a views. Have you heard about the term called as table and views in database? Right? It clubs all together and the query was subjected to this master node. I want this data, so this will get processed in the master node. So eventually with the growth of the data, what used to happen? My master server was overloaded, right? And it was a lot of effort to upscale it. Cost was involved, lot of maintenance was involved. You can scale it to certain level, right? Vertical or horizontal, but management becomes very difficult. The Hadoop concept just make it reverse. Okay. So this was master server. Now I call this as a You understood, right?
Yeah.
Where was the data residing? Data was earlier residing here,
Yeah.
right? Processing was happening in the master node, bringing all the data. So when you bring the data, there are two factors involved. One is IO operation, input and output operation, reading a data from the database and writing it to your destination, right? That operation is called as IO, right? It's a very resource intensive task of reading and writing IO operations, right? If I just reverse the concept, I will call this as a name node, right? And I will call this as a data node. You all have one name node, one data node, right? In your laptop, right? Think about there are 4 data nodes. When you do the first command, which is called as put, remember in the assignment you did a put command, right? I gave you send to Hadoop path and you write HDFS, EFS, something like that, minus put. Then you give the source path, right? C drive left there, and then you give the Hadoop file system path, right? What was it doing?
Was transferring to.
It was taking from Windows machine, desktop location, my document, whichever folder you were there, right? And picking up the data and putting it into your Hadoop distributed file system. Since you have only one data node, it was only putting there. If it was 4 data node, the data will be split, right? It will be split. So it's the same thing if I write it, and Hadoop file system says the file path is /Harish. 1 to 100 line number will go. I'm just giving a number, okay? 1 to 100 will go here. 101 to 501 will go here. 502 to 1001 will go here. And let's say 1002 to 5002 will go here. I'm just giving a number, right? What is happening? A big file is split into smaller file. Where is data residing now? Come on, guys, where is the data residing?
Data is residing in each of those.
Data is residing in the data node, right? Now, if the name node then, as part of your assignment, what did you do? I told you to run a jar, map reduce word count jar, right? What did you give here? A path, right? You gave a path where your HDFS file system file is loaded in the first step, right? You gave the text file, right? What did it do? You fire this jar, it has got 2 processes. One is called as mapper, other is called as reducer. First, the mapper runs. So since you have only one data node, let's say this was your data node. Your request went here. Process the mapper, process the reducer, and give you the word count. And this word count was sent to the name node to see and view an output for you, right? As a success or fail. Now think about you have 4 data nodes. Same file split into 4 different categories, 4 different small segments, and the same jar was sent to all the 4 people to perform the same task. Where is processing happening?
In the data nodes.
I am only sending the instruction. Where is processing happening? In the data node. What is master node doing? Master is doing nothing. Master is just sending an instruction to the data node. Boss, you all do this. Once you are done, bring your copies, I will see it. That concept is called as data locality. Processing is not happening in the master node, processing is happening in the data node. Why? If it is happening in the data node means processing is happening in the place where the data is actually located, not at the place where data is brought. Do you understand?
Yeah.
Okay, so that is called as data locality. Send with the data to the nearest cluster node. So if these data nodes are residing in one cluster, basically in one data farm, then it is the same cluster. If they are split into different cluster zone, different countries, different geographical area, then it will go to the nearest cluster node to fetch the data and process it. Clear?
Yeah.
Hadoop is composed of 3 components: Hadoop distributed file system, Hadoop MapReduce, and yet another resource navigator or yarn product. Right? I told you this 3 components. Concept of master slave architecture is implemented to organize data processing and HDFS store. So what do you understand with this diagram? Who is the master? Name node is the master, right? Who is the slave? Data node is slave. What type of architecture we are dealing with? Master slave architecture, right? Clear?
Yeah.
Okay, so the 2 layers in HDFS presents are, one is called a HDFS layer and another is called as MapReduce layer. What is the task of HDFS layer?
The stuff's the data.
Just ingest the data,
Yeah.
get the data from the source and put it into HDFS file system. That is the task of HDFS layer, right? HDFS layer uses what? It uses name node, it uses the data node, right? Why, what task it use the name node for? The task it use the name node for is to put the file, right? So name node is responsible to putting that file to where? To data nodes, right? Here in this diagram, if you see name node also have a data node, you can have it like in your laptop. Name node and data node is residing in the same machine, right? Let's say I give you another few Azure cloud VMs. So one data node will always be there in your laptop, right? Remaining will be there in the cloud, right? So what is the HDFS task here is? HDFS layer task is to get the file, name node will tell where to put in the which of the data node. Clear?
Yeah.
What is the map reduce layer job? Map reduce layer job is when the instruction is sent to the data node, they need to perform two operations, mapper and reducer, right? So what it will do, map reduce will have two tasks, two jobs running. When I say job, we call the word as a daemon in Hadoop. Either you call it a process, either you call it daemon, or either you call it task. Everything means same. So in Hadoop, we use the word called as daemon. Daemon is nothing but a process. So it runs two processes. One is a task tracker, another is a job tracker. What is the job of job tracker? Job tracker is, think in this way, put myself as a part of a name node. Okay. Put you all self as a data node. Okay. And let's say you are going to give an exam, right? Give an exam as an assignment. I take a huge file, right? I give each you one huge file. I split that file into 30 people here. I give some section of the file to each of you, right? As a teacher, what I am supposed to do? My task is what? To give you a job. The same thing is done by job tracker. When I give a task to you, that's my job. Name node job as a part of map reduce layer is job tracker. If I've given you, what are you doing with that job? Are you doing it? Are you not doing it? Are you suspending it? Are you canceling it? Whatever process you are doing. But I have to keep a track, right? If I give you the job. Map reduce layer in HDFS has process called a job tracker who keeps the job track of each of the slave node or the data node where the processing has been progressed. 20% done, 30% done, 50% done. I have to keep the track, right? Slave node will process, right? Instruction is sent by the name node or the master node to the data node that run the map reduce program. When the map reduce program is sent to the slave node, I need to track it, right? That job is being done or not, right? That job tracker will tell which data node is available, which data node is down, is the processing going slow, is the processing going fast, is there available disk space on that machine or not in the slave, is the disk is full or not, is the system is up or running or not, right? I have to keep the track, right? Just think about as a student, you all have to keep the job tracker. What is the task tracker task? Task tracker is to ensure that the task is completed or not. If I give you an assignment and some people take an assignment and go home, what will I do? For me, task is failed, right? The data node task is failed. Some people will be taking the work and but not able to complete in time. What will happen? Expiry time, right? Time required to complete the processing exceeds the required number of time which was supposed to be given to execute it, right? All those things is being done by task tracker. Why it is done is in order to increase the reliability. So think about, as I gave you an example, if a job is assigned to you and you are not able to complete it, or let's say you took the paper and went home, what will I do? For me, that data is lost, right? Isn't it? That data is gone.
Yeah.
I don't want that situation. I need to make sure that there is no data loss. What will I do?
Sure.
I will track it, but if somebody runs, what will I do?
You have to, that's why you explained the last time that somebody else also will have a
Copy of it. That's called as replication. We will keep a copy of the same thing somewhere else, so that if some data node or a slave node is down, I can ask the other data node to pick that work and do it for me. Right? That's the concept of job tracker and a task tracker. It tracks the activity that is running. Okay? two layer, one is HDFS layer, another is called as map reduce layer. Map reduce layer will do the job tracker and task tracker of the instruction of the map reduce program that is being sent. What is the instruction that is sent? Mapper function and the reducer function. When those functions are sent to the data node, I need to track whether the mapper runs successfully on the data node, whether the reducer runs successfully on the node. If the reducer was run, was the data returned to the name node or the master node once completion is done, right? I have to see all those things, right? In order to track it, I will keep this two job running on the Hadoop architecture. Clear?
Yeah.
Good. Name and data node, which I already explained to you, it's the same thing, right? You have a master node, name node, data node has got data node, node manager, map reduce program. Again, this map reduce program is sent by the name node to the data node to process it. Okay? Clear?
Yeah.
One question to you all. What will happen if the name node itself goes down? It can happen, right? Isn't it?
Yes.
Data node, I told that, okay, you will have a replication of data.
Yeah.
So similar to that, master node is also replicated. When I say replicated means a failover is created. So when you have one master node, you have a adjacent backup master node also running. Because in case a master node goes down, I can rely on the other through a load balancer. Okay? Yeah. HDFS master slave architecture, name node known as master node. It manages the file system space and execute operation like opening, closing, renaming of files and directories. We will see into the details what type of operation name node performs in the functional level. Previous slide I told you two things happen. One is HDFS file system management and second is called as map reduce operation, right? This one, right? This two, right? We will see this in detail, how the file is written and how file is read. Okay, this one is map reduce program, which you have already done, but when we go to assignment 2, you will write a map reduce program in Python for mapper and you will write a program for reducer. Again, you don't have to write it, there is a code which I will give you, you just simply have to run it, but you need to understand what the code is. You don't write map reduce program anymore, okay? In the industry, we don't write it. We use a direct package, okay? Name node master node manages file system space and execute operation like opening, closing and renaming of files and directories. It maintains the file system tree and the metadata of all the files and directories in the tree. The name node also maintains and manages the slave node. Okay? Block size. What is block size? What is block size? If you split the file into smaller portion, what is the size of each file should be? That's called as a block. Okay. By default, it is set to 128 MB, but it can change depending on the configuration of the system you want to split the data. Okay. File associated with the metadata, again, few more things. The name node. So whatever name node you see here, right? We will write it here one by one. What are name node tasks? Okay. One task of the name node is a manager of HDFS file system, right? Right. What it will do when the file arrives to it, it will take the file and load it to HDFS file system. That is the data node. Correct?
Yeah.
The second task is it will do a map reduce process, right? When I say it will do means it will not do, it will send that request, the data node will do it, right? Now, when the person is writing a file to HDFS file system, think about when you are copying a file from any friend's give, let's say email came to you, got an attachment, right? When you take a copy and you write it into, let's say D drive, my document somewhere / some folder and you save it there. You do it, right? You get any file, what do? You save it in a specific folder location. How do you remember you have saved it there?
The name.
You remember by name, right? But it's in your mind, right?
Yeah.
Or is it that when you open the computer, oh, look, you have this data here.
No.
It doesn't tell you, right? So who will tell this name node that where the data has gone? Obviously, right? You took a data and what did you do? You split the data into data nodes, right?
Yeah.
You wrote the data, same file into the different data nodes, right? Yes or no? Till this point, you
Yeah.
wrote a file in and you uploaded it to HDFS file system.
Hmm.
Who will keep where the data is? In your laptop, you are doing assignment, you have one name node, one data node, very simple, right? Right, name node knows that there is only one data node, I have to search there and my file will be there. Let's say there are 5,000 data nodes. And you have one file which is split into 5,000 different places. How will a name node knows when somebody comes searching, knocking the door of name node saying that I need this data? Can you find it from MapReduce?
The map,
How will it find? But MapReduce will run, but where?
There should be a memory somewhere where you keep.
Somewhere
tracks
that
of-
information needs to be there, right? That information is stored in a file called as FSL image. Understood? File system image, Hadoop distributed file system image. What does it store? It stores metadata. Okay, one is data, right? What is metadata?
Metadata is the information that keeps information of a data.
Yes. Data within data is called as metadata, right?
Information.
So if my data is stored at, let's say I have kept my file in room number 413, the metadata will be
Room number.
Seneca College, K wing, 4th floor, room number 417, east side. That's the metadata. Detailed dictionary information of where the data is residing. So when I store the data in the data nodes in the split format, where is my data stored? That information is stored in FSL, FS image, file system image.
Okay, so
Basically, it's a snapshot of the data storage information. It's a dictionary of where your file split data is stored. It includes the data node name. When I say data node name, it's not stored by DN name, okay? It has got a full alphanumeric name of the slave node. It will tell the IP address, it will tell the partition place, it will tell the position of the block, it will tell the start data point. It's like an index to the pointer level information is stored in FS image folder. It's a snapshot of the information where your data node is storing the data. Why? Because when the next step of MapReducer program runs, data node, I don't have to search on all the data node to find out where the data is stored.
Yeah.
I can simply see the image where the data is stored and directly target that place and fetch the data and fetch it. Correct?
Yeah.
Okay, so that is a persistent checkpoint of the file system metadata, correct? Then there is something called as edit log. It contains all the recent modification made in the file system with respect to most recent changes. Edit log is another format of recording the changes that has been done on this FS image file. Somebody can do the changes in this, right? Let's say one data node is down, it's no more available, the data is lost, but the replication is here, I have to update this, right? I've added a new node where the split of data is happening, I have to update this. Right, so edit log is working as a secretary to the FS image file. Any change or any modification that is being done in FS image file, the record of the change is kept in edit log. So that if the problem comes, I can revert and go to the previous state. Clear? Is this clear? This one? Very important, this too. Okay, again, you are not going to touch these two files, you are not being allowed to do it also. Okay, you can only read it when you do in a big organization, but these are the things you are not going to even touch it. They don't allow you to see it also. Okay. The senior lead architect will do this all work, okay?
Okay.
Then comes data node known as a slave node, it performs read and write operation as per the request of the client or the name node, okay? And it reports back to the name node periodically with a list of log that it is storing, clear? Secondary data node, so as I told you, for replication purpose, you create more slave nodes, right? Secondary data node, just to keep more reliability. Secondary node usually runs on a separate physical machine. Its role is to merge the FSL image and edit log from the name node periodically. This prevents the edit log from becoming too large. It also stores the copy of merged FSL image into persistent storage, which can be used in case name node failure happens. Okay? Yes or no?
Yeah.
So secondary name node is like a backup plan. Right, so you keep all the updates of FS image and edit log files in a secondary storage also. In case your name node goes down, you have a backup copy. Okay. In Hadoop, processing model works in data locality, which I already explained to you, where computation logic is sent with the data to the cluster node, right? Processing is sent to the data node, processing is not happening in the name node. The computation logic is compiled version of program written in high level language such as Java or Python. This is the jar or map reduce program which is written in the high level language that will be actually sent to the data node to do the processing activities. When there is a need of another set of node in cluster, computation logic can be moved closer to the data, not the other way around. So if you need more processing, you can spin up more data nodes and you can run it more closely to your name node. When I say closely more to the name node, I will get into the next slide, which is called as cluster. And I will explain you what does it mean closer to, okay, or nearer to. I'll explain you, just keep it. Data locality concept I have already explained you. Okay. Okay. How many of you understand people have heard about the word clusters? Cluster. Can anyone give me quickly within 2 minutes what is cluster?
So cluster is when in terms of server, when you bring them different servers together, perhaps most of the time performing the same task. It's just it's also near to load balancing. Just a group of servers coming together to perform.
It's a group of machine. Clusters are nothing but a group of machine. It can be a server, it may not be a server also. Think about cluster as a library room. Have you all seen library?
Yeah.
You have the aisles, A, B, C, D, right? Aisle. If you think each aisle as an aisle and each row has number of shelf, that shelf is called as a rack. Okay, I'm using the same word because it's the same word which is used. Each aisle is there. Let's say there are 5 aisles, A, B, C, D, E. Each aisle is one aisle, and each aisle there are number of shelves.
Yeah.
If I take shelf from bottom to up, it's called as one rack. Right? You can have many racks in one aisle. Yes or no?
Yeah.
Right? If I go in aisle A, I can have A rack, B rack, C rack, D rack, right? 1, 2, 3, 4, right? If in each rack, if I put small machines, when I say small machine, like your desktop, this is the CPU, right? If I take this and start putting one above the other, can I put it? One machine, two machine, one above the other, pile up like a book.
Yes.
Right? If I take a network cable, you know network cable, right?
Yeah.
That wire which you connect through internet in the back. If I take one and connect to the other, take one and connect to each other. So each of the machine will be interconnected 1:1, right? If I take this wire and connect to a switch, you understand switch?
Yes.
A port where every network wire is getting punched in. So one rack will have its own switch and will have so many servers associated with it, right? If I take multiple aisles and then all these aisles are connected through another switch, main switch. So entire system is connected. Let's say this library of this rack is in Seneca Newham campus. This is Newham, right?
Yeah.
I have another Seneca campus in Markham. Same thing, I built it there. And then I connect both together. So this one thing is called as one data center. That is called as another data center. Okay? Within a data center, if you have a rack of machines hosted in one another connected to each other is called as a cluster. Okay? So you can have a data center in one city, another data center in another city. You can have group of data center in one continent and a group of data center in another continent. So when you study a cloud concept, you will study about that. There are geographical data centers, right? So what happens is when you store the data in Hadoop, what happens? I told you data is split, right? When the data is split, it's split into data node. Since your laptop has got one data node and one name node, you know the file is in your laptop. Let's say there are 5,000 machines which are in a different cluster across the globe, right? When you upload your file, you want to make sure the data is residing closer to you. Why closer to you?
For easier
reduce latency.
Network time delay will be reduced, right? If you have to fetch, if I have to search some data which is in Japan, it will take more time from data center to be retrieved there than come here, right? It will add 1 or 2 second network delay. I don't want. So what you do is you do a concept of reducing the closest, which are the word I was using, right? What is called as closer. This line will be moved closer to the data, not the other way around. So you try to keep the data closer to the master node or the name node so that the retrieval is in quick time. Right, but it has also got a challenge, right? If you keep all of your split data into, let's say if I have a HDFS file system hosted in Seneca, I split the file, I kept everything in the Newham. Tomorrow Newham data center is down, what will I do? Entire data is not reachable, right? Because all the data nodes are down because everything is in the Newham campus. Now if I split the data in a way that some portion of the data I will keep it here, some portion I will keep it in Markham. Or I will keep a copy of both of it. Right? What will I benefit? One is reliability. If this is down, I can pick it. Only the trade-off will be the slowness, right? So that's why whenever you configure your Hadoop, you want to ensure that the data distance between the rack, distance between the data center is as minimum as possible. So that delay of network is reduced. But if you need more reliable system, you can't, it is said now, you don't keep all the eggs in the same basket, right? Same concept goes, you don't keep all the data in the same data center, you split the data into different data center, right? So that's all the concept of.
Do you split it or you replicate it? You split
You
it.
split it and replicate it. So if there is one file, big file, I split it into 4 parts, A, B, C, and D.
Different data
So
center.
if I take A, I put one in Newham and I put one in Markham. If I take B, I put B in Markham, B in Newham, right? So why? Because if normally I can fetch everything because it is closer to Newham. But in case Newham data center is down, I can pull it from there, right? Okay. As DFS instance run on the cluster of computers spread across many racks, the communication between node of different rack has to go through switches. Right? I explained you switches, right? It's a connection medium between different racks. Mostly the network bandwidth between the node on the same rack is more than the between the machine on the separate rack. So if a data is in, let's say, aisle A, another data is in the aisle B. If the data is A copy is there in the aisle A in one place and aisle A in another place, it will be faster because in the same rack, right? Versus data in rack A versus rack B. Again, when I'm saying faster and slower, it will be in millisecond, but again, it makes sense, right? When we are dealing with huge volumes of data, right? This is typical data center looks like. Okay, same thing which I explained you, right? These are all called rack. Anyone has seen data center anywhere? Your college is the data center. Your college is the data center, right? So you can see the data center, it is nothing but a group, hundreds of CPUs and like it's like a, think about you will have this small computer, this small, like a size of a box. You can just put it one above the other and connect it through switch. Okay, so if I say Azure cloud is being used as a data center, Azure has got, I think 4 or 5 different continents. They have this data center, one in Europe, one in Brazil, one in North America, one in the East American, West, like one is in Toronto, other is in San Francisco. One is in China, one is in Japan. So these data center, what they are doing? They are nothing but a group of servers joined together. Google has made a data center in Pacific Ocean, below the ocean, right? In a cylinder, which is a vacuum cylinder, fully air conditioned, right? It is connected to internet. That tomorrow, if let's say nuclear war happens, they still have a data to be stored in the data center. So they bring it out every 7-8 years. You will see even Microsoft guys will pull out the data center, huge, like a trolley cylinder, right? They have all the machine inside it and all the air conditions to cool it down, right? All the information is stored there. If you need a reliability that no, I don't want any data to be lost. My service should be, that's why they in cloud you will see they will provide the reliability up to 5.9. Is 99.99999. Basically one failure in every 100 years. So you saw, maybe you people have heard few, maybe 3 months back, 4 months back, there was a big Azure cloud failure. Have you heard about it? I think in September. Have you heard about it? Nobody heard?
I know that.
There was a downtime of 4 hours. in which the Azure cloud was not accessible. So no Boeing online ticket booking was possible. Air Canada booking flights were cancelled. Air traffic control was down. Real-time monitoring of many systems are not working. What happened was somebody in the Microsoft team had a security patch. Security patch, you understand, when you get a Microsoft update, right? What do? You get what do? You blindly click next and install it, right? Microsoft released a security patch for everyone in the cloud, means to all the customers who are using their cloud services. So my company was also using, every company in the world was using Azure cloud services. The package was not verified and tested properly and deployed in the production, means it was sent to all the virtual machine to be deployed automatically. As soon as it deployed, the services came down. Again, it was $1 billion huge loss, and there was a lot of court cases going on to get this penalty paid by Microsoft. But 4 hours is a huge time, right? You can understand how much business loss it will be. You read it, you will get it. Microsoft Cloud, I think it was some security patch name. I forgot the name. Our system was down also. Like I have around 180 odd virtual machines running on cloud. And I have close to like 24 or 26 virtual machine which is in my lower environment, means testing environment. When this thing happened for 4 hours, none of my application was running. And I was raising a ticket with the production support team in Microsoft. They said, sorry, we are having other priorities because they are big clients, right? They are huge, bigger clients than RBC, right? Right, who were pressurizing them to fix it. Nobody was seeing the lower environment. My lower environment was down for 6 days.
Wow.
So none of the thing was moving, no code deployment in the lower environment, no checking validation was happening. It's a huge loss, right? More than like I think 300 or 400 billion dollar loss was there in 4 hours.
For your own company or for Microsoft?
For my company.
Hey. No.
It's huge. It's like you can understand 4 hours you cannot do anything. It's a huge thing, right?
Yeah.
Think about there are big clients also, big customers also, bigger than RBC. JP Morgan is there, you have Citibank is there, you have what is that? Huge bigger companies. What will they do? Think about the biggest challenge was the airline company. They had a biggest loss. Their ticket booking was not going through. The payment system was not going through.
You have to host custom passengers on hotels, e-hotels.
Okay, so this is single node cluster which you have done on your local machine. Single node cluster means data node and name node residing on your local desktop, like the assignment. In a multi-node cluster, I explained you if the data node is residing on multiple clusters, then it is called, that system is called as multi-node clusters. Clear? Communication protocol, HDFS communicates over a TCP/IP protocol, a regular protocol which you use for other communication mechanism, right? Clear?
Yeah, so
Data node, name node talks to data node through a method called as remote procedure call. How many of you know what is RPC, remote procedure call? Have you heard about it, RPC?
it looks like RBC.
No, it's not RPC. Okay, remote procedure call is a mechanism where the actual code execution of the function happens on the some other place versus the source location. Think about if I am going to do an add operation 5 plus 4. One way is I do 5 plus 4 operation on my own machine. That is 9. The second mechanism is 5 plus 4, 2 argument, I give it to someone and say that take this to number and do an add operation and give the result. So when I give it to someone else, the process is happening remotely. What operation is happening? Procedural operation is happening, or the function operation is happening. That's why it is called as the remote procedure call. Okay, remote procedure call is an example. If you go to Google and search for a calculator, you open a Google and type 100 multiply by 100. Calculation happens, right? Calculator calculates it. How? Calculator is not built in Google Chrome. Where is calculator? In the Google server, right? What are you passing as a request? Only the argument, right? Where is processing happening? Remotely. Any process where the process happens remotely, that process is called as a remote procedure call. How many of you have studied C++ in their 11th, 12th? You all have studied? Which language did you study? C++. C++. Has a function called as call by argument, call by method, call by argument, call by value. You remember? Where you write an integer, add bracket integer x comma integer y, and then you define the add function c equals to a plus b. When you pass the address of a location where data is stored, that is called as call by reference. That is nothing but remote procedure call. Your main method is not doing addition. Your main method is jumping to the function where it is written, processing it and giving back you the result. That process is called as a remote procedure call. It is very, very commonly used in Java. Okay. Okay, two more things. One is anatomy of file read in HDFS. I will explain you how file is read in from the HDFS file system. Basically, I'm going to explain if the data is already stored in data node, what are the steps that are being performed to read and pull the data out of HDFS. Okay. First is your client sends a request. Okay, that I want this data. What are you going to do? You are going to open a connection. Okay, it's like someone coming to your home. Let's say I came to your home and I want to pick up something in your room. What will I do? I knock your door. What you do? We open the door and say, oh, go and pick it up. You do this.
I go pick it
No, I'll
up.
pick it up for you. I'll pick it up and.
Why will you pick it for me?
I was touching.
So let's say if someone comes to your home to fix your let's say water heater,
That one.
knocks that door,
No, that one.
what will you do? The knock the door is called an open connection. What are you going to do?
I'll open the door for him to come in. Yes.
Just okay. So I will not come to your home, then it is bad habit. You shouldn't be. So if I knock your door, what do you do?
I'll ask the reason
You
why.
will ask me, who are you? Where are you from? What are you doing? You are basically authenticating and authorizing me whether I'm allowed to go inside or not. Correct? And the next thing you are going to ask me, what do you want? Right? What do you want means get the block address or location what you want me to read from. So person opens the connection, distributed file system, HDFS file system will see whether that location or the block information is there in the name node. When that information I'm saying is there in the name node is picked from where? FS image file. Correct?
Yes.
Distributed file system got that yes, this file is located. I know the place where in the data node it's there. Should it give it to me? Should it give it to me or no? No. You need to authenticate itself. Right? You give anything to your home, somebody comes and you give it.
I thought you already anticipated the point of it.
No, I open the connection, distributed file system. Will say, okay, you need this. Okay, let me see whether that is there with me. But before I find that, let me know why you are here. You are authorized to see it or not. What do you want? Where you want? What is the purpose of your visit? But what I am doing in the back. I'm also checking where this is there. Once this is authenticated, I'll allow HDFS client to read through FS data input stream method. This is a function name. File system data input stream and read the data from the different data node. Once it is authenticated and authorized. Clear?
Yeah.
How long it will read? So I wanted to read 10,000 lines. I started reading. Two options. I read the entire file. All 10,000 information is collected. I said, okay, all done. I updated distributed file system. Yes, read complete, success, okay, acknowledge. I disconnect the connection. Happy path, right? What is the negative path happening? Or worst case path? I started reading the file 10,000 line and suddenly at 5,000 line my connection breaks. Happen, right? My data node goes down. What will happen? Half I have read, half I have not read. What will I do?
You are authenticating.
So what I will do, I will read the file till the point I am able to read it, and every time when I am reading it from the data node, I am sending an acknowledgement. This is read. This is read. This is read. This is read. Oh, this is not read. When I message the FS input stream file that acknowledgement has not been received, distributed file system will find another data block where that data is residing because it has got the snapshot of the location on the other data node where the data is kept. And it will pass me that information. Oh, pick it from here. If this is broken, right? This is very seamless. You will never know it happened. Okay. So if you ask me visually, can I know it failed? No, you will never know because the system is so fault tolerant from the front end, you will never be able to know that fault has happened until unless you have only one copy of data available. Then only the failure happens and you say data node is not available. But since the replication is there,
Will there be any time lag difference if a node fail?
no, you will not be able to visualize it. If I said 200 millisecond delay was there, can you estimate 200 millisecond? You cannot know. But the log people who analyze the system and maintain the production system, they read those logs. Was there a fault happened? Why that fault happened? Under this situation that fault happened? Was the utilization high or the data node was corrupted or whatever, right? And they fix it. Okay, so that process is mentioned, and once the data is completely read, the connection is closed. Is this process clear? Okay, let's go to the write process. I'm not reading it, okay, guys, you all can read it, okay, step by step. How the first step was read. Now I have to write it. Writing means writing the data into HDFS file system. In your assignment, you just did a put statement, right? You don't know how the write has happened inside, right? You don't know how the partition happened, how the block was created. You just got an output, yes, file successfully loaded in HDFS file system. And the name node you can see, a data node, you can see that file is loaded. You don't know the split, right? Internally, how the loading happens for write is HDFS client, basically you and me typing that put command. I want this file to be loaded in HDFS files. Client is nothing but your command line argument. It can be any UI application, it can be it can be a batch process, anything it can be. You want to load 100 gigabytes of file here. When you try to write it, are you allowing to anyone to knock your door and do any modification in your house? What will you do? You will first create a connection, right? Requesting to create a connection. When you create, there it was open for read, writing request create. I want to create a connection in distributed file system. When you create a connection, it goes to the name node, requesting to create a connection. Create a connection to where to write? To write to the data node, because the name node has to tell where to be written, right? So that create process, when it is sent, it also authorizes whether this person is legitimate to be allowed to be written into the data node. Again, there are many layer of authentication. You are entitled to write in some node, you are not entitled to write on some nodes. That's been designed by the architect again. You're not allowed to write every place, right? There are some sensitive data, we don't want people to write it. There are some general place we will ask everyone to write it. Okay, so when the create connection happens, name node tells which data to be written, it will give the address. Distributed file system will say, yes, this person is authenticated, connection has been established, these are the location of the data node, go and write it. Now all the write information will go from FS data output stream. This is again a method. In case of read, it was FS data input stream. For writing, it's FS data output stream method. What it will do, it will serially start writing the data node. Now, when it is writing in one data node, as I said, you need to have a replication, right? You don't want to keep only one and only master copy. You want to keep a subsequent copy. Once the data is written in the data node 1, depending upon your replication which you have set it, let's say you have asked for 4 replication, it will write into the 4 data node. You ask 16. For our organization, we have 16 replication because we don't want any data to be lost, because it's a client specific, sensitive business financial data, right? I don't want to have any loss of even 1% of the data. So I write the data in 16 times parallelly. When I'm writing, 2 situations can happen. Either your data is completely written, you get an acknowledgement and you close the connection, right? You know the data has been written. Name node will update the FS image file saying that this is the place, this is the data which is stored in this data node. Second case is you start writing and half you have written and the data connection is broken, right? What will you do? Same case, every time when the packet is written, an acknowledgement packet is sent, successfully written. Wherever the acknowledgement is not received, FS file system output stream will pass that message to distributed file system saying that the process failed. It will retry. When it retries it, either it can retry the same data node or retry another data node to write it. So in this way, your data is written. Clear? Once the data is written, the connection is closed.
You are saying that, like, an example, your company, you replicate it 16 times because you don't want data to be lost. What's the definition for you don't want data to be lost? Maybe an organization will choose 4 times. You are choosing 16.
Again, it depends on the business requirement, right? It depends on if your data is not so sensitive and you think that, okay, I can have a certain form of a slowness acceptable.
Okay.
I can have one copy in Newham and one copy in Guelph. And one copy in, let's say, Germany. Fine, right? You can accept like, okay, if tomorrow flood comes in Guelph and Toronto, at least Germany is working, we can still get a data with a lag of, let's say, half a second. Acceptable. But I don't want even that to happen. So I want to keep the copy in 16 places. So that even half of the world is down, I still know that my data can be recovered from other place. Right? It depends on the business requirement, because whenever you do the replication, you are adding a cost to the system. Remember that there is a cost associated with it. Whenever we are adding more and more replication, we are basically using the disk space and the memory and the virtual machines. Someone has to pay for it, right? If your business is enough capable to hold that cost, that's fine. It depends on how much reliability you need, right? Okay, so there are some Hadoop commands which you can check it out on your local machine, like mkdir, put, get, you already have done, copy. Again, those are all same command, move, cat, tp. Okay, those are same command. Remaining command, you can see it in a Hadoop shell command link. Again, you don't use so many commands. If you have done the DOS and shell basic command, ls minus lrt and all those stuff. List, right? And then you have grep, AWA, SED, these commands are used in Unix, right, or Linux. If you have done those commands, you can easily use it here, same command, same syntax, okay? That's it for today. Any question on the people on the Zoom link? Bhumi, Pooja and Rosca. Any question from you all? No? Okay. I would be stopping the video. Any question, you let me know. 1 more minute. I will send you this updated TPP slide. Please go through the concept again in the slide in detail, read it. If you have any questions, please ask it to me. I will help you out to explain it. Okay? Okay, guys on the Zoom link, I'm stopping the recording and closing the Zoom session. Thank you.